So now that you guys have an idea of what an object is, um, we are going to go over some differences of an object and a primitive type. So almost everything in JavaScript is an object. So the arrays that we were doing is an object, and so are all of these other things that we're doing. Console is an object, right? Um, but the only things that are not objects are the primitive types that we've been working with thus far, which are booleans, numbers, and strings. So that means that everything else is pretty much an object. Um, booleans, numbers, and strings, they can be created using the new keyword, like you saw with new object. You can do new number or new string, though it's not typical. You can do it, and then they too can be objects. So there are very important concepts that you guys really need to understand for this. The the three concepts are mutability, value, and reference. So mutability means that whether you can change, whether you can reassign something or not, whether you can delete something or not, how changeable is it? So primitives in JavaScript, and this is it's kind of a pain because it can be different in every language, but in JavaScript, all primitives are immutable. Okay, they cannot be changed. They must be reassigned. Objects are mutable. Okay, that means that you can change them without reassignment, and you're going to see this. I'm going to go over these in this example, and in this example it's commented out. You're going to see that. And then also passing into functions, these two things, right? So passing by value and passing by reference. So passing by value, when this number hits this, uh, comes into this function, it what it does is it makes a copy of it, and then it works with that copy inside of this function. And then the number outside here is going to stay the same. Okay, and you'll see that in the code as well. Reference, it doesn't copy. So if you pass something in, and if you pass an object into here, that's what this little section is talking about is primitives are passed by value, objects are passed by reference. Okay, so objects that are passed by reference, if you pass it into here, it's going to stay the same everywhere. It's going to stay the same out here as well. Okay, not just within the object. So whatever you do to an object inside of a function, it's gonna it's gonna stick outside of the function too, and you're gonna see that. So here we have a little bit of code, um, and in this code we're passing. We have a number here. Okay, number equals 1, and this is a primitive type, and we're going to console log what it looks like before it goes into the function. And then we're going to call it with the function in it, and then it's going to increment it by 1, and then we're going to console log inside of the function, and we're going to see what number is inside of the function, and then we're going to console log it outside of the function again after the function is called. And we're going to do the same thing with this object here. So here we have the function object example method, and we're going to pass in the object number, and this object number is just an object here. You see we created with a property that's num, just like this num here, and we're setting it equal to 1. And of course, we are going to increment it here. And we're going to console log the before, during, and after. Okay, so let's go ahead and run this and see what this looks like. Okay, so here, the first three lines you can see. So is the primitive type. So primitive type, when you pass it into a function, the starting value is going to be 1. Okay, inside of the function, we can manipulate this and do whatever we want to it. It's going to stay 2. Okay, it's going to be 2 inside of the function. But then when it's done, okay, when it returns and it comes back here and it executes this line of code, okay, when it comes to line 68 here, it's going to again be 1 because it forgets what this was. Because remember, this is a copy being passed into it. Okay, it's like copying it in. Okay, now with objects, it's a little bit different. Okay, you can see here. So the starting value is 1, right? That's what we have here. It's 1. And then inside of the function, when we call this function, the function object example, it's going to go in, it's going to increment it. We're going to console log of it, log it inside. Okay, so here it is, inside function object example equals 2. And then we're going to console log its value out here again afterwards, and you see it stays 2. And again, that's because the object, okay, the object is passed by reference, where the number, the primitive type here, this regular primitive type, is passed by value. Okay, and that's a very important concept to know, because if you pass in a primitive value into this function example and you do something to it and you return it and you think something's going to happen and it doesn't, right? It just stays localized to this function. Whatever kind of changes you do to this primitive value stay inside of this function, okay? And then after it's done, it executes the function, returns back to the caller, comes back out here. It forgets about what happened in here and it just goes back to normal, okay? It's like Vegas, right? What happens in Vegas stays in Vegas. Same thing with these functions when it comes to primitive types, okay? What happens in these functions stays in these functions. Now for objects, again, it's different, because objects, they are passed by reference. So what happens inside of this object doesn't just stay inside of this object. Everybody else is going to know about it, right? So it's like posting your experience on social media, right? You go to Vegas and you put it on social media. So, that's kind of like almost the equivalent of that. Um, and that's why you see here, before it goes to Vegas, it's a 1. During Vegas, it's a 2. When it comes back from Vegas, it's a 2 as well. Again, right? It stays a 2. So, all right. So it's very important to understand that concept with how primitives and objects work when you pass them into functions. Okay. So the next thing we're going to go over is comparisons and copies. Okay. So comparisons. Um, okay. So again, comparisons are also done a little bit differently. So when you compare two primitive values, they are compared by value, right? They're compared just by the value itself, okay? Um, Objects, on the other hand, are compared by reference. So the reference is, okay, so this is kind of a little bit outside of the scope of this course, a little bit, not really, but it is. It's a little bit more in-depth computer sciencey stuff. But the way that objects are created, they're created in something that's called the heap. Okay. And this heap has a special address. Okay. And that's what they compare. They compare these addresses when it comes to and each object has its own special unique like address, right? It's like its own little house. Okay. And objects are handled differently than just primitive types. And so when I say here it's compared by value, it is quite literally the value of the primitive type. Okay, and by reference, reference means it is comparing the addresses of these two objects to see if they're the same. Okay, so that's why it's going to be false. So here, you know what? I'll put another example here, and we'll do just object num. Okay. Ah, okay, this will end up being true. And so will this. Okay, so let's run this, and we're going to see if my comments here are correct or not. So this is going to be true because num, where is num? Num is up here. Okay, we need to not comment this out then, because we need these. Okay. Okay, so all right, there we go. So again, this will be true because num is 1. All right, remember it stayed 1. Um, this is going to end up being 2. Okay, and this is just another anonymous object. Remember, you can instantiate these wherever you want to. So we're just creating an object with the number 2. Okay, and we're going to run this. Okay, so here we go. So you see the first one is true. Okay, That's this one. And we're comparing num, the primitive num, to the number one, and that's fine. Then we're going to get two falses here, okay? These two are false because even though the number is 2, these are different objects, okay? These are different objects. And then these two are true because, well, they're the same object, right? So just keep that in mind when you compare objects. It's not so easy to compare objects. Um, there's tricks you can do. You can Google them if you want to, if you ever have to compare objects, you can do that, but just be aware of this. The best thing to do is compare IDs. Usually, if an object has, I mean, these don't have IDs. So you would do something like dot ID, right? Dot ID, dot ID, dot ID. Okay. Um, so you can this is like common practice if you have objects. If you're ever working with objects, there'll be some kind of identifier. Usually it's an ID, could be like a, I don't know, social security number, though you really shouldn't be using those in production, but or in anything really. Social security numbers are scary to work with. But anyway, so yeah, so that's how comparisons work with objects. And the next thing we're going to go over is how copying works or reassignment. Um, So reassignment is also pretty unique. So reassignment, when you when you reassign when you reassign a primitive type, so we have num here, and we say num2, you're going to see we're going to have the before values, and then we're going to increment num2 by 1. And we're going to have the after values, and we're going to see what happens when we have those. The same thing with the object, right? So here we have a num object, num object 2, right? And we are going to, again, we're going to see what the values are beforehand. We're going to increment object number 2 by 1, the number inside of it, and we're going to see what the output's going to be and what their values are going to be after the fact. So let's see. Okay, so here is the before, and for the, oops. So this is the So this is for the primitive values, okay? So before, you can see we have number 1 is equal to 1, number 2 is equal to 1, and then we're going to increment number 2 by 1, right? So now we're right here on this line of code, line 99. And now afterwards, you see num stays as 1, and num2 goes to 2 because we incremented it. Now, that happens because you're copying, remember? So you can see here primitives are copied by value where objects are copied by reference. Okay, so these are two different, completely different items, right? They're two different addresses, all right? And that's why they don't change together, they change independently. But when you go to objects down here, you see the before, we have object number is 2, object number 2 is 2, and then we're going to increment object number 2 by 1, right? So now we're here on line 110. And you see they both actually increment, right? That's kind of weird. And why does that happen? Well, that's because when you do what you see in line 105 here, when you set an object equal to another object, they are the same object. They are pointing to the same memory, to the same address, okay? The same house, right? So that's why they both change. And I know this is a little funky the first time you see this, but this is to get into the nitty gritty of it. It would require us to get into pointers and a bunch of other stuff, and it's just for now, just understand that this is how how objects work, and that's how primitive types work. Okay, and it just depends on what you're copying, right? It goes back to these fundamental ideas of value and reference. Okay, so that objects are always going to be references. All right, they're always going to be references, and primitive types are always going to be passed by value. Okay, that's really the main thing you need to understand, and that is exactly why the output is the way it is here. Okay. All right. Well, if you guys have any questions, let me know. In the next lecture, we're going to go over what classes are. So we're going to have regular classes and how to create classes. Okay. And then we're going to talk about the differences between all of these different things. Okay. All right. See you in the next one.